now move on to the topic of prenatal environmental influence. This was an issue related to the relationship between siblings and fraternal twins. The prenatal environment influences later development even as far as adulthood. Now, environmental influences are always understood as a thing that comes from outside your body. Air, water, food, drugs, sunshine, they are all outside of you and you acquire them so that they are all considered environmental influences. However, the environmental influences don't start on the day you're born. They start for anything that's outside of you even before that point. So even during the prenatal environment, the amount of oxygen and nutrients you get while you're a fetus is still part of an environmental structure. The air your mother breathes, the food that she eats, those are environmental influences on the development of the child. So the psychological traits of a child are going to be affected by those prenatal environments because those traits are going to be managed in part by the amount of environmental influences that comes in during these early times of development. So the most relevant aspects of a prenatal environment typically comes through the mother's blood supply. That is the blood and oxygen and nutrients that the child receives through the mother's umbilical cord. Now, one of the other alternatives that's related to the prenatal environment that's very important is the placental arrangement of the child if he or she is a twin. When twins are born, they could have either been in one of two placental arrangements, as you see here. In arrangement A, the twins will share one placenta, and in arrangement B, they will have their own placenta. Now, based upon everything that I've said, I think it's probably a reasonable estimate to predict that the children in arrangement A will actually be slightly more similar in personality characteristics and in other psychological traits than the pair in set B. And that is actually true. It's a very small effect, but it can be measured in a large group statistical study. So doctors at the hospital record the placental arrangement of twins when they're born, and psychologists can come in after the fact and collect this information over the course of years and then hunt down those twins and give them personality and aptitude tests and other types of psychological tests to evaluate the relationship between their personalities and skills and abilities, and relate that to the prenatal environment that these children had from 20, 30, 40 years ago. So you do see that the prenatal environment actually does have an effect. It is a small effect, but it actually is there. What you tend to see is that of the two twins, one of them will likely have a slightly larger diameter umbilical cord. That is, through just natural statistical variability, the umbilical cords won't be exactly the same. There'll be slight differences between them. And that's not to imply that there's anything wrong with the umbilical cord itself. It's just that they won't be the same size. Between the two twins, whichever one has the larger diameter umbilical cord, you wind up with a higher birth weight, generally a higher IQ, and you also tend to see a more consistent temperament, so less likelihood for wild fluctuations that occur during the day. So as I mentioned, these are very small effects, but they can be measured in adulthood 20 years after the children are born, which is clearly indicating that the prenatal environment is affecting the genes of the children, and that's one of the components in which you see that genes and environment do not function by themselves in a vacuum, but rather they always influence the opposite factor. So the environment does modify basic biological functioning, including genes, and the genes and other biological properties do modify the way in which you experience the world. Now let's take a look at this question. Which of the following is most highly weighted toward an environmental factor in prenatal development? And the answer is A, your mother's diet. For the child, as well as the mother, diet is going to be very much an environmental aspect. What I'm really referring to here is the food that the mother eats. And that, of course, is going to produce fat and protein and vitamins that the child will need. Your mother's genes is certainly a biological process. Father's ethnic background is completely irrelevant. It's not a biological or an environmental aspect. And family history of mental illness implies a genetic aspect. To look at how gene and environment interact with each other, we should look at a wide range of examples. Because I keep telling you that no psychological trait measured in the past 4 decades has either been completely biological or completely environmental. Every single one tested so far seems to show that it has both a biological and an environmental component, but that depending upon the response system, some things are either more highly weighted toward biology or more highly weighted toward the environment. So if that's the case, we should look at a wide range of gene-environment interactions to get an idea about how these things influence each other. So let's start on the category of genes influencing the environment and evaluate how your height, personality, and your abilities influence how your environment is processed. Your height is more likely influenced by your genetics rather than your environment. But as we're going to see in the next column, your height can be influenced by the environment. But for now, let's just focus on the fact that you have some height. It was created some particular way. Whether it was genetics and environment, it doesn't matter. You are 5 foot 4 inches tall, you are 6 feet tall, whatever it might actually be, you have some particular height. How will that height influence who you date? Right? You don't see very many 5 foot tall men dating 6.5 foot tall women. Okay, in fact, that's a common principle of attraction that you see around the globe. Generally, men tend to be taller than their wives or their girlfriends. Of course, that doesn't have to be, but again, this is statistical reasoning. Playing sports. Your height will influence the sports that you're actually going to be good at, and therefore the ones that you're going to enjoy playing. So some sports will be better played for a taller person, like volleyball or basketball, and some sports there may not be any influence on height whatsoever, such as fishing. Personality. You have some personality. Regardless of how it was created through biology and environment, you have something right now. Now, how does that personality influence the friends you choose? Well, if you are a very extroverted individual that likes to dance and be the center of attention, chances are you're going to find friends that will go along with this kind of thing, possibly very extroverted individuals as well. If you're a very introverted person and you like to stay at home and read or watch Netflix, then that's going to wind up affecting the number of people and the specific people that you become friends with. The same thing happens with recreational activities as well. If you love sports, and it doesn't matter what sport you play, just so long as you're playing something because you're competitive in nature and you love to do active things, you'll play basketball, then you'll play street hockey, then you'll go for a jog, then you'll lift some weights in your garage, and then later on you'll contact your friends and see if they want to just shoot some hoops later at night. constant process of doing sports. And in this case, you're going to have to find people that can keep up with you. And there's going to be a lot of people that are not going to want to play that much sports. But if that is what you're interested in, then you're going to have to find the select individuals from society that can actually do that. And your abilities. You have some set of abilities, regardless of how they were created through genes or the environment. There are abilities that you have. You're great in math. Well, how does that affect your choice of a career? Now, if you're really good in math, you're actually in a select minority of individuals. And with that being the case, you may realize, as most people probably do, your salary can go up really fast with some math skills. So having a degree in engineering, for example, will really vastly put you ahead financially if you're able to get that engineering degree in 4 or 5 years, as opposed to a history degree, which is simply going to pay most likely less. Types of life success as well. The types of abilities you have of any sort will wind up affecting what you consider success in your life. So if you're very good in artwork and you take a career in art or something creative, the types of life success that you may think about is whether or not you ever get one of your own paintings into a museum. And that may be something that you consider. If you're really good in athletics, then you might consider whether or not you ever get to play professional ball. If we move to the right column and look at how the environment influences the genes, these are some of the stranger ones that you're probably not familiar with. Now, again, your height. You have some height. It was created through a bunch of genes and the environment. How did the environment influence the activity of your genes? Although the specific biochemical pathways are not understood in all ways, we tend to be, in general, at a time period in which we can clearly identify that it does influence things, although the specific biochemical pathways that operate it are not completely understood. So, for example, nutrition clearly affects an individual's height. Anywhere you go around the world, for people that live under starvation conditions, they tend to be smaller individuals. Certainly not necessarily the adults who may have grown up with food, but if there's a drought or food shortages now, the children that are growing up under those circumstances will tend to be shorter than the previous generation and shorter than other members of societies in which there are no food shortages. So one question you could ask is, could you feed somebody so little that they would only grow to be 2 feet tall? And the answer is no. That doesn't seem to be the case. In fact, there's a broader part of the story here that it appears your genes give you a range of heights of which you can actually grow to. So there's a minimum and a maximum height that you could grow to based upon your genes. Where you reside within that range is largely determined by the nutrition and exercise you get during the time in which you're developing. One of the other instances that you see here is that height is influenced by touch. Now, this is a very odd one, but in research on infants in intensive care units, touch has been used in scientific studies as a way to stimulate a person's immune system. And by massaging neonatal infants, you can actually activate their immune system so that they improve in health more rapidly. One of the things that was found in research like this that was later expanded upon by psychologists was that the children who were massaged in the neonatal unit tended to grow more quickly. So psychologists kind of picked up on that topic and wondered whether or not a child's adult height could be associated with the amount of appropriate touch that they receive from their parents. And in correlational studies, it turns out that there is evidence for this, that in families in which no touch occurs, children tend to be shorter than in families where there's lots of hugging. Let's move on to personality. How can the environment influence your genetic expression of a personality? The events that occur to you during the course of your life modify your personality. Personality is not completely determined by your genes. It's determined by both genes and the environment. As I've said, everything measured over the past 4 decades has indicated it's both genetic and environmental. But there is always the question of to what degree is it genetic or environmental. So in this case, in terms of personality, social events that occur during the time that you develop, especially at younger ages, may wind up affecting your personality. This, of course, should sound somewhat common for modern psychology, but the idea is that what happens to you when you grow up influences your personality. And that shouldn't be very much of a far stretch overall, because that environmental theorizing has been around for well over 100 years. It's just that we've included now the aspects of genes. So to make this statement today, that the social events that occur during your development, such as growing up during the Great Depression or growing up during the time when the internet was fully functioning as it is now, or developing during the 1950s when there was a consistent Cold War threat from the Soviet Union, are all things that wind up affecting people's personality development. And of course, personal life histories as well, if they're not broader social events like a Cold War or the Great Depression, they may be things that happen to you in your life, such as your parents are raising you, and then they both die in a car accident. You, as a 2-year-old without parents, are brought by the police to the foster care system, and then after that, from a consistent loving family, you wind up hopping from foster home to foster home to foster home because it's just your bad luck that you wind up being placed in bad homes and wind up getting bounced around a lot. Then, through the process of life history, you may learn not to trust people or to reserve how quickly that you warm up to people because you have a history in which people always leave you. Your abilities as well. If you have great ability in mathematics, that expression of your math ability will not really be raised to its highest levels unless you have formal mathematical training. So when you think about, for example, the Dark Ages in Europe, how many people during that time, for hundreds of years, could have potentially been great artists or scientists, except they lived at a time before science existed and before they even had an opportunity for formal schooling for their math ability or to be able to be creative. An individual that biologically has the potential to be a great author will not have the opportunity to express that type of behavior if they're never sent to school and become literate. And so there's no telling what loss of potential is there when you don't give opportunities to an individual, because looking at a child, you don't automatically know what their abilities might actually be. And that's one of the things you always see with parents is they provide opportunity after opportunity after opportunity for their children to give that very wide range so that if there's anything in there that the child can kind of hop ahead inability, you'll wind up catching that and being able to focus on it afterward. And this, of course, is true even with modeled skills by family members. The abilities that may be present in a family, even though it might not be present in the one individual target person, might likely become more well developed simply because they are raised in a family where everybody does this sort of work or has this particular skill. So in an artistic family, if there's one child that's born that's not especially artistic, there's a good chance that just from growing up in a household of artists that this person will learn about creativity and may be able to draw or paint or play the piano a little bit better than most other people. They won't necessarily be the greatest at it, but because they grew up in the environment with these opportunities, you would wind up seeing a skill in them in adulthood. So, which of the following are likely affected by genes and the environment? Well, I hope the answer to this one is really obvious. It is E, all of the above, because that is what I'm saying to you over and over and over again in this chapter. So how can gene-environment interaction operate? Well, what I'm going to do now through a couple of slides is give you an idea for the basics of how genes and the environment may interact with each other to form an ultimate adult personality, level of skill, intellectual ability, and so forth. How can genes influence your behavior? Well, prenatally, before there's any learning or memory really being formed, you have neural cells that are creating your brain. Right? So at this point in time in development, really mostly everything is being driven largely by biological processes. There's not a lot of environmental influence at this time, and certainly you don't have those adult level processes like memory and sensation and perception and so forth that you're going to wind up saying. We're talking about 1 month after conception, and your brain is growing off of the top of your spinal cord. This is mostly a time where you would refer to biological processes primarily controlling everything. Now, the genes in those cells are going to make proteins, right? That's the basic rule from chapter 2. Genes' primary job is to generate proteins, and then those proteins have different jobs around the body. Now, the proteins are going to modify your neural architecture. So as your brain is developed, the genes in the cells will release substances that will affect the neural architecture in the neighborhood of cells that will create parts of the hubs or areas of the brain that will be formed with one architecture or another. Most of the discovered heritable traits have substantial emotional components to it. Now, keep this in mind. Back in chapter 2, I gave you the basic statement that 100% of your brain has the potential to operate 100% of the time, right? So there's not an action potential in every axon at all times, but nothing ever shuts down and is cut off from the rest of the brain. That means that your limbic system is always operating. Now, even though your limbic system is always operating and everything you do always has an emotional component so that it's always there, you do consistently see that many of the heritable traits have especially strong emotional components to it because there are strong motivating factors that influence the pattern of behavior that a person will exhibit. For example, your personality traits. Personality is a topic we're going to cover weeks from now, but it essentially talks about patterns of behavior that are very, very stable over the course of your entire life. And for a pattern of behavior to be very stable over the course of your life, it has to be something that the person would express that they are comfortable with. And so you'll have a high degree of comfort with particular patterns of behavior. You like to be active, you like to be extroverted, you like to be the center of attention, or you like to stay at home, you like to be introverted, you like to read a book. All of those patterns just feel natural to you and comfortable. And so you see a very close connection between your motivation to behave in a certain way and the personality traits that you have. The same is also true with intelligence. For the skills that you have, like if you had a great deal of artistic ability, you would probably excel in that case and you would probably enjoy doing those tasks. So the type of intelligence that you have or the particular trait that you are very good at shows an interest in the individual. They like to play the piano. So you say they have an interest in playing the piano. They like to do math problems. They have an interest in math. You always have that high degree of motivation related to intelligence or personality. Now, in terms of psychological disorders, you're not going to say that somebody has a high interest in being mentally ill, but what you do see is that every single psychological disorder that you identify, that we will talk about later in the semester, all have strong aspects of emotional activity that are part of the disorder itself. There are almost no psychological disorders that do not have a strong emotional content that is part of the disorder itself. There are a couple, one of them being personality disorders, but they are a minority of the overarching story of psychological disorders. So there's a tendency to see that the emotional reactivity of a person is going to be connected to that psychological disorder. And then finally, again, going back to the limbic system still, your temperament is most certainly the way in which you respond to events. The degree to which your emotions swing high and low over the course of the day, or whether or not you stay relatively stable regardless of good or bad events. That's not to judge one and the other is saying good or bad. There's no judgments in this case. It's just a description of how a person behaves. But what you do see in point number 4 here is that for the most common aspects that are clearly associated with both genetic and environmental causes, that there is always a consistent pattern of emotional responding that's related to those traits. Now, the genes that are responsible for creating the pathways through the brain are also going to be the same genes that wind up affecting the degree to which circuitry innervates your limbic system. So the degree to which any of your systems that regard thinking processes or perceptual processes are linked to your emotional systems are going to be very much a genetic issue at the earliest stages of development. Okay, the earliest stages prenatally. Later on, your brain will still be developing after the point at which you're born, and more traditional types of environmental circumstances will then go to modify the degree of wiring of these thought processes to your limbic system, mainly through the basic process of neuroplasticity, the rewiring of your brain through environmental contact. So you will see across individuals with different types of personalities and intellectual skills and so forth, that pathways may be broader or thinner than in other people. That is, the pathway that connects a thought process to one particular aspect of your limbic system will simply be of a wide variety across individuals. Some people, there'll be a very strong connection. For other people, simply be a smaller connection. Some of the brain areas that control patterns of behavior will simply be larger or smaller than they are in other individuals. That doesn't have to be by much, but when you look at individuals, you can find essentially a normal distribution of sizes of areas of your brain. So for example, if you measured the size of the amygdala across a wide variety of people, you would find a normal distribution of the size of the amygdala, and the people at the high end with the largest amygdalas very likely would show much more fear and aggressive behavior, and the people all the way at the very bottom would show much less fear and aggressive behavior. In fact, those people would probably be much calmer in general, much less likely to get into arguments. And of course, the same story holds true with neurotransmitters, because neurotransmitters are nothing more than proteins that were created by genes. And those neurotransmitters are going to modify the function of the neural pathways, as we talked about back in chapter 2. The degree to which those neurotransmitters are held in vesicles and released into a synaptic gap so they can affect the receptors that are on the dendrites is all part of the story of how activated you can get a particular neural pathway. So these genes produce hormones at critical stages of development over the course of your life. Probably one of the most relevant ones is going to be puberty, where an entire shift in behavior will occur as a result of changes in the concentration of hormones, which again goes back to your genetic development. And those hormones, of course, are going to modify behavior across your lifespan. Those behaviors that the hormones modify are going to have to fit into the local environment and the general culture in which you live. So in some cases, that hormonally driven activity is going to be suppressed by society, and in other societies, it may be allowed to run wild. It just depends. And what you're actually seeing is from the point of conception all the way to the point where you're actually interacting as an adult or maybe even a teenager with members of society, there is such a large string of different events that modify how things process each step along the way that it's actually rather difficult to make general statements about how everybody's going to behave. You can make broad-based statistical estimates, but what's going to happen to one particular person always requires more specific detail about that single individual. This is completely unlike physics, for example, or chemistry, where an oxygen atom is an oxygen atom, and it doesn't matter whether it's on Earth or out in space, it's always just an oxygen atom, and it always does the same thing. And that's just not true in psychology. The process that's relevant, or even the physical structure of the brain, is constantly being modified by its context, whether it's a social context or biological context, and things change step by step by step by step from the point at which you're conceived until the day you die. But there's never a point that anybody's ever seen that the system just shuts down and stops changing. Always have continued change. Nothing remains the same. So in the bottom, you see from genes to the construction of your neuroanatomy, and then your neuroanatomy's modification of the behavior, which is, of course, being modified by the rules of society in which you live. Now, one of the nice places where you can go to kind of selectively identify issues with respect to gene in the environment is related to gender identity and sexual orientation. And the reason why this works out well is because gender identity, sexual orientation tend to be a very select pattern of behavior. And you can rein in the parameters on what you're actually looking at in this case. So it serves as a nice model to investigate the story of gene-environment interaction. So even though there's a broader range of things that actually exist, we're going to focus on the most likely scenarios. Genes tend to be either XX or XY. XX is female, XY is genetically male. Those chromosomal patterns are going to wind up affecting hormonal release at puberty, so that male and female hormones in puberty are going to be different processes. which should not be any big surprise. And of course, learning from the time that you're born until the time that puberty occurs, you learn how boys act and you learn how girls act. And so when the hormones kick in and you've already identified yourself as a boy or as a girl, you then enhance that prior learning because you're motivated to do so as a result of the higher concentrations of estrogen or testosterone that are in your blood supply. So if you take a look at those categories, 2 out of 3 of these categories are biological. The genetic and the hormonal ones are both highly weighted toward biological causes. Genes cannot be changed with current technology. So if you were to try to do experimentation on this process, you could not take an infant boy and switch his genes to XX and then have him grow up as a girl. Right? That's not a technological process that we're able to manage today. And certainly, if tomorrow some geneticist found out a way to do that, you still would not be able to do the experiments because it would violate ethical standards. Right? You would have to find out a way to do this and then replace the person back into infanthood with the proper genes that they were originally born with. And that's so far off. That's bizarre technology into the future that I can't even imagine. Now, the genes can't be changed with current technology, and hormones may be affected by the environment, but are most likely not. Right? Hormones can be influenced by the environment depending upon the life experiences of a child when they're leading up to a puberty. The life experiences will wind up affecting when puberty begins. So, in fact, one of the topics that has been studied many times by psychologists is that female children without a father in the house tend to go into puberty sooner and develop more rapidly than if a father actually does exist in the house. And that's the only change. There's a dad lives in the house or the dad does not live in the house. And that affects the likelihood of the onset of puberty for a female child. That is very much an environmental influence on the development of hormonal activity. There must be a wider range of events, but that happens to be one of the ones that's more widely understood at the current time. And finally, gender-type behavior in learning follows typically your physical development. So as we were talking about, other than these 2 primarily biological processes of genes and hormones, you learn what a boy is, you learn what a girl is. So when you become motivated to behave one way or the other, you already have that pre-learning to establish it. And this gives you kind of a setup for understanding how genes and environment interact with each other to establish things like gender identity and sexual orientation. And in fact, one of the ways to really see this play itself out is to do an experiment that really could not be done ethically. It has to be done by accident. And this is the case of John Joan.
When you are that desperate to have your child helped, and here comes somebody saying it's fantastic, it'll work, you'll believe anything for your child's happiness.
This man, who asked us to disguise his identity and change his voice, is known in medical literature as John Joan. John for when he was born as one of a pair of normal twin boys, and Joan for the years he spent being raised as a girl after a surgical accident left him with virtually no penis.
When the doctors came out to tell your mother about the accident, what options did they give her?
They didn't have no options. He just told her, he says, we can just change him into a girl and no one would ever know the difference.
So John became Joan, the family and everyone else acting as if the twins had always been one boy and one girl. Joan wore dresses and was encouraged to play differently than her brother. Why would anyone think it could work? The theory was babies are born a blank slate when it comes to gender, And just as children are taught language, they learn to be male or female, almost from the moment they get a pink or blue card in the nursery. It seemed to work well for John Joan. According to this Time magazine article from 1973, when Joan was 10, this dramatic case provides strong support that conventional patterns of masculine and feminine behavior can be altered. And these medical textbooks are full of advice for doctors that sex assignment at very early ages works, based in part on how well the report said things turned out for Joan. There was just one problem. The reports were wrong.
It was a flop. It was a failure. Sorry.
But yet the medical literature for years had said that you were a success story.
Well, you know, if they call that a success, well, I don't know what to say. I mean, I'm telling you that I'm living proof it was not a success story. I mean, it's BS.
How could they have gotten it so wrong? I mean,
They wanted to. They wanted to believe it.
bad science?
Yes.
Dr. Milton Diamond of the University of Hawaii never bought the blank slate idea. What he found out, published in this medical journal, turned the John Joan case upside down. When Diamond located John Joan, he did not meet a happily adjusted female, but rather someone who had been living as a male again for roughly 20 years, and who was quite bitter about his past.
I thought I wasn't it. That's what I thought it was. I mean, I thought either I wasn't it or I was crazy, because people are telling me who I am, but I realize what girls do, and I wasn't anything like that.
Do you think the doctors did the best they knew how then?
No, because I showed all the signs that it was not going to work, but they wanted it to work, and they let it go on and on and on. I mean, that is maddening.
Rather than looking between the kid's ears, they look between the kid's legs. And if it looks good, they think they did a good job. Again, they're reluctant or not even trained to ask the kid how they're adjusting.
Joan was not adjusting well, even though her genitals looked like a normal girl's. Other kids sensed something unusual about her and teased her about not being very feminine.
I had like I don't know what you would call it. I think maybe it was a nervous breakdown. I'd cry for nothing. I'd have the shakes. I'd be huddling in a corner. And
Finally, after years of knowing something was wrong and battling doctors and therapists who told him nothing was, at the age of 14, John gained the strength to say on his own, "I am a boy." That only began a new nightmare. He stopped taking female hormones right away, but it took years of new surgery to reconstruct a penis. And even then, he wasn't free to just start life over. To this very day, even though he is now married with 3 adopted children, he lives in constant fear of people finding out about his past, while at the same time struggling with it himself.
Was it difficult to have the reconstruction done?
it was very, very painful.
Can you have sexual relations with your wife?
Definitely.
Can you feel anything?
Definitely.
Could you father biological children?
No, you would have to get your testicles intact for that.
Does the fact that you look like a man, you sound like a man, you walk like a man, make it easier now as an adult to put any of this behind you?
No, I mean, how can you put something like that out of your mind?
According to Dr. Diamond, the lesson of the John Joan case is that gender identification comes from the brain, not the genitals.
So from that video, let's take a look at one of the very last lessons we have here that kind of pulls together a lot of this material on nature and nurture, but into its modern form. That is the biopsychosocial model. The biopsychosocial model is a model created in the early 1970s that mixes together the processes of nature and nurture, but does it with respect to the more recognized value of influences in the 1970s, as opposed to the original nature-nurture story that was created in the 1880s. The biopsychosocial model covers the 3 basic factors that modify human behavior: biology, psychology, and social behavior. But what you should really recognize in this case, because biopsychosocial implies that there's three things: biology, psychology, and social. It's really the nature-nurture story from the 1880s. It's just that the nurture component, or the role of the environment, has been split into two specific factors now: psychological and social. So this is really biology versus psychosocial functioning. And it's important that you recognize that the psychological and social are just reflecting the environmental aspect, but different components of it. So you have a more detailed view of nurture at the current time than you did in the 1880s, when Sir Francis Galton coined the term nature versus nurture. So in terms of biology, that is just what you think it is. It's anything related to basic biological functioning, usually referred to genes in this case, or neuroanatomy, or hormones. Those are the basic aspects of biology. Now, in terms of nurture, the environmental component, you're talking about psychological or social functioning. Now, there's a key term here that you have to be aware of: psychological. Psychological means something very specific in terms of the field of psychology. Psychological means personal life events. That's what that means specifically. So whenever you hear about a psychological trait or a psychological factor, it refers to something that happens to one particular individual in their life. It's not a global social aspect like the Great Depression or the rise of the internet. Psychological processes are things specific to that individual. So you may have a Great Depression or the rise of the internet, but how does it influence the day-to-day activity of a single individual? So environmental influences specific to one person refers to psychological. And then the social aspects refers to the environmental influences common to all members of society. And why that's important in this process of development is because you will leave your house. You will come across strangers. You'll be with people you don't know in stores and in school and in your work environment. And there are rules to engage individuals that will be met with reward and other ones that will be met with punishment. And you have to learn those rules. Some of those rules will fit your personality characteristics, some of them won't. And it will continue to modify the way that your brain functions through the process of interacting with other individuals. So this biopsychosocial model is really the modern version of nature versus nurture. And be aware, nature versus nurture is not really a thing any longer, right? There is no question about nature versus nurture. Every psychological trait measured since the field of behavioral genetics got started at about 1980 has showed that every psychological trait has had a biological and an environmental component to it. So when you hear stories about nature versus nurture today, that's just somebody really not checking their facts, or maybe using that term in a more generic sense. But there really is no nature-nurture debate. Everything, at least in terms of psychological processes, not necessarily underlying biological or medical things, that's not part of our story here. Psychological functioning, all psychological functioning tends to be influenced by both biology and the environment. So there's no versus, there's no debate. It's that everything is both biological and environmental at the same time, and that each specific response system is either more highly weighted toward biology or more highly weighted toward the environment. And that basic nature-nurture story is represented in a more modern form here in the biopsychosocial model, which takes the environmental component and splits it into the psychological and social aspects, and contrasts that with biology. So let's look at one final question before we finish. Which of the following are affected by all three components of the biopsychosocial model? Well, that should be an easy one, of course. The answer is E, all of the above. Which foods become your favorites, who becomes your spouse, your intelligence level, or even your types of aptitudes, your personality types, and even the likelihood that your personality changes over the course of your life are all modified by both the biology and the environment, so they're all represented by the biopsychosocial model. It's important to recognize that this biopsychosocial approach is going to be used all semester long because it is the modern version of this entire process of understanding biology and the environment. And so we will always refer back to it. And you, as a new psychology student, should recognize that this is one of the lowest level basic processes with respect to all behavior. Either behavior is modified by biological principles or environmental ones. Of course, there's going to be an interaction between the two, but there's really nothing else outside of that realm. There's either biology or the environment or some interaction between them and nothing else. This accounts for, in the broadest sense, not very specifically, but in the broadest sense, the entire range of control for human behavior. And that concludes the chapter on nature and nurture working together.